Okay, in this video, let's talk about the part 4 of this section 1.2. Part 4, solve problems that can be modeled by quadratic equations. That can be modeled by quadratic equations. Okay, so this is a word problem. It's a little bit long, so let's be patient. First, let me copy the problem. So from each corner of a square piece of sheet metal remove a square of side 9 centimeters. Okay, turn up the edges to form an open box. Turn up the edges to form an open box. Okay, so this is a procedure. For example, you have this square piece of sheet metal and you remove a square of side 9 centimeters. So here you cut a square from each corner. Cut a square. This is 9 centimeters. 9, 9, 9, 9, 9, 9, 9, 9. Okay. So technically now you have a cross, horizontal, vertical. And then you're going to fold up this piece. That's what it is saying. Remove those 4 squares and turn up the edges to form an open box. So that is a procedure. Okay, if the box is to hold 144 cubic centimeters, so basically just say the volume of this open box is 144 cubic centimeters. What should be the dimension of the piece of the sheet metal? What is the original dimension? Like, what is this side? It is a square, so you only need to know the one side of this sheet metal. Okay, so that's a question. Okay, very good. Let's check. We're looking for the side of this square piece of sheet metal. So let x centimeters be the side of sheet metal. Okay, so this side is x. This side is x. Now we only know that the box has a volume 144 cubic centimeters. So how do we measure compute the volume of the box? When you have a box, the volume is equal to the area of the base. Area of the base times the height. Okay, so the volume of a box is equal to the area of the base times the height. When we turn up the edges to form the open box, then this side, it is turned up vertical, so it becomes the height. So in this problem, the height is 9 centimeters. Okay, so see here, this is the 9 centimeter. You turned up, so that's a height. And the base of this open box is this square. Remember, the original sheet is a square. You remove 9, 9, 9, 9 from each corner, so the internal stuff, the base is also square. The base of the box is a square of the side. What is a side? Here, this is a side. The side, you see, all here, they're all side because it's a square. This is x. The total thing is x. Here is a side. The side plus 9 is x. In other words, the side is x minus 9 and minus 9. Minus this corner and minus this corner. This is size, which is x minus 18. The side is x minus 18. Correct? When you get the side, it's a square. So the area of the base is x minus 18 squared. For a square, the area of the square is the side squared. Okay, so A is x minus 18 squared. H is 9. And volume is given, the box is to hold 144 cubic centimeters. We have area of the base times the height is equal to the volume. Area of the base times the height is equal to the volume. So this is a quadratic equation. We're going to solve this quadratic equation to find out x. Right? Okay, to find out x. Now let's solve it. We divide this equation by 9. The 9 is the coefficient. We divide the equation by 9. Divide it by 9. 144 is divided by 9 is equal to 16. So we get x minus 18 squared is equal to 16. And this is a square root method, right? We take square root, we will get x minus 18 is square root of 16 is 4, or x minus 18 is negative 4, either positive or negative. Right? And then continue this, we will get x is 18 plus 4. You move 18 to the right side, it's a plus. 18 plus 4, 22, or 18, move it to the right side, it's a negative 4 plus 18 is a 14. So at this moment, you have two solutions. X is either 24 or X is, either X is 22 or X is 14. But you have to go back and check it, okay? So for the 22, you cut you cut 9 from each corner, then the base becomes what? This 20, the side of the base is x minus 18, right? The side of base is x minus 18 is 4. Okay, the height is 9. It's always 9. It makes sense. And when x is 14, the side of the base is x minus 18 is negative 4. Now you have a problem. We are talking about the real question. In the real question, the side of the square can never be a negative number. This cannot happen. This cannot happen. The side of a square is never going to be a negative number, and there's no negative side. Okay, so this means x equal to 14 is not a solution. It's not a solution of the problem. It is a solution of the equation, but it's not a solution of the problem. We're talking about a real problem. All right? Okay, so now you only have one answer. What should be the dimension of a piece of sheet metal? So the dimension of the square piece of sheet metal is 22 centimeters by 22 cm. Okay, so that is the dimension. You have the sides, and this is the complete solution. Of course, I write several sentences, which may not be necessary when you answer the question in the exam. I just try to make this answer as complete as possible. So in the exam, you need to set up the variable. You need to figure out the equation. You should be able to solve the equation, and you have to verify it. Sometimes not all the solutions of equation are the solutions of the problem. So we have two things. One is a problem, it's a real world. One is the equation, it's abstract world. The answer may satisfy the abstract world, may not satisfy the real world. Like this, there's no negative side of the square. Okay, so you must verify. You must verify and see if there's some crazy stuff happen. Okay? Okay, let's do another exercise similar to this. The word problem. Okay, so let's see. Uh, 95 on page. What is a page? 102. Problem 95. Yeah, 95. So find the dimensions of a rectangle whose perimeter is 22 meters and whose area is 40 square meters. 40 square meters. So we're trying to construct a rectangle so that the parameter is 26 meters, area is 40 square meters. Okay, so rectangle has two sides and the other two sides are duplicated. So let x be the longer side of the rectangle. Two sides, one is bigger, one is small, or maybe they are equal to each other. Okay, whatever, let's see. X is the longer side of the rectangle. So based on this drawing, x is here. This side is x. By the geometry, we know the opposite is also x. Right? And two vertical, two left and right sides are also the same quantity. And because the total parameter is 26, so the shorter side is, what is the shorter side? So first, 26 minus 2x, 26, remove those two sides, and then times 1/2. Because after you remove x and x, you still have two such identical vertical sides. And you divide by 2, you will get just one side. This is the shorter side, correct? Shorter side. The shorter side is 1/2 26 minus 2x. And if you simplify it, you distribute 1/2 into the parentheses. 1/2 times 26, 13. 1/2 times 2x, x. So the shorter side is 13 minus x. Correct? Okay, so you have the longer side, you have the shorter side, and you can compute the area. The area is one side base times the other side height. It should be 40 square meters. Okay, so this is the equation we are interested. Okay, so do you understand how I got this 30 minus x and the equation x times the 30 minus x equal to 40? Okay, good. If you get it, let's try to solve these quadratic equations. Let's do the multiplication. It's 13x minus x squared is equal to 40. And you move 40 to the left side, you will get negative x squared. We always copy x squared term first. Negative x squared plus 13x and minus 40 equal to 0. Okay, and we prefer the coefficient of x squared to be positive 1, so we multiply the whole thing by negative 1. Multiply it by negative 1. I just want to make this coefficient positive. Minus 13x plus 40 equal to 0. Okay, so this is a standard form of a quadratic equation. You have several ways to solve it. One of the way is to apply the root formula, the quadratic formula. What is the quadratic formula? Here a is a 1, b is negative 13, c is a 40. So you check b squared minus 4 is c. b squared is negative 13 squared minus 4ac. Negative 13 squared, you compute it. it's 169. Just do the computation. And 4 times 1 is 4, times 40 is 160. So the difference is 9. It's positive. It will have solutions. Okay, then x is 2a, 2 times a, negative b. B is negative 13, negative b is 13, plus or minus square root of 9. Square root of b squared minus 4ac, discriminant. Okay, so 13 plus or minus 3, square root of 9, 3. So x is 13 plus 3 over 2, which is 16 over 2 is 8, or x is 13 minus 3 over 2, which is 10 over 2 is 5. So you again have two solutions. You have two solutions. Okay, and then you have to verify it. Every time when you do word problem, you need to verify it. When x is 8, the shorter side. What is the shorter side? The shorter side is 13 minus 8 is 13 minus 8 is 5. Well, it looks okay. And here, or the shorter side is 13 minus 5 is 8. Well, this is not good because shorter side is 8, longer side is 5. It doesn't make sense, right? So it does not satisfy the problem. We assume x should be greater than the other side, not less than it. So there's only one choice. So the dimension of the rectangle is 8 meters by 5 meters. Longer side is 8 meters, shorter side is 5 meters. The total parameter is 26 meters and the area is 40 square meters. Okay, very good. So this is the application of a square, the quadratic formula. If you can observe it, actually from x squared minus 13x plus 40 equal to 0, you can factor it. The thing is that 40 is a 5 times 8. 1 is 1. Coefficient of x is 1, so you factor it as 1 times 1. 40, you get 5 and 8. Into the product, you get 8, here you get 5. So this is 13. But we need a negative, so you put a negative sign here, negative sign here. You have to put them together so that negative 5 times negative 8 is still positive 40. You cannot just put 1 and then leave the other one unchanged. Then you will have negative. And if you have a negative sign, this is negative 13. And then you put x, so you get x minus 5, x minus 8 equal to 0. So x is 5 or x is 8. The same thing. Same thing. You see 8, 5, 5, 8. Doesn't matter. And at this moment, you still need to verify it. You verify them based on the same reason. This term not good because it's supposed x is supposed to represent the longer side. Based on here, x represents the shorter side. It does not satisfy the situation. So you still just have one solution. It doesn't matter what method you use, you should have the consistent answers from different methods. Okay? So this is another example about the applications and the models of quadratic equations. Do the recommended exercise, especially for those word problems. If you have any questions or any doubts about the geometry, because word problems possibly depend on the geometric formula. You have to know the area, how to compute the area, how to compute the parameter, how to compute this side, that side. There's so many geometry there. If you have any questions, send me email. I'm happy to answer those questions. And also, all the required formulas, the geometric formulas. Let me see. All the required geometric, at the end of the textbook, there is a collection of formulas. Some you may use now, like geometric formula. Some you will use in the future. So there is a collection of formulas. Okay, so you should be able to find some useful one in this part at the end of the textbook. All right. Okay, so we finish this video and we will continue the next video about the next section. Do your exercise, ask me questions if you have. Thank you. We finish.